Hello everybody and welcome back to another video. Today I'm actually going to go over something pretty basic in Linux. This really isn't actually anything to do with VMware, as most of my videos are, but considering I've been kind of jumping around a little bit and helping people out with certain aspects of certain tutorials I've been doing, I thought this might actually be very important. It's the permissions for Linux and how to read them. So when you're looking at something that has read, write, execute, how do you know which files are yours? How do you know what works with what? So I thought I'd just do a quick video on explaining how that is. Now, for the most people, it's kind of intimidating. They look at it and go, I have no idea what this is, and they get confused. But it's actually fairly straightforward and easy to understand, especially if you've never actually even used Linux. So what I went ahead and did is, once this thing opens, is I actually create a really quick, cheat sheet for your Linux operating system. What this is doing is actually it breaks everything down. Now, it doesn't go into full details, like, for example, how the permissions is actually broken down into binary and stuff. That's how the system reads it, and that's how they come up with the numbers. We don't need to know that. We just need to know the basics that pretty much say, listen, I need to add write permissions to the actual program here, the file, the folder. So how would I do that? That's what I need to know. And that's what I'm actually here to explain to you. So the basic breakdown of permissions is very simple. You have three groups to worry about, or three pretty much basic permissions. You have the U, G, and O. Now the U stands for user, and that's normally the owner of the file or folder. Then you have group, and group is usually whoever the owner is usually attached to. So for example, if my name is admin, usually the group that I have is admin as well. But I can be attached to, say, like wheel, which actually multiple people have access to it. Or if we're creating a business and I have the HR department, the group would be HR, and I would be the HR manager as user. And then other is exactly what it means, everyone else. So if you don't fall into the user or the group, then you're into the other. All right, very straightforward. And then you actually get the file attributes, which is R, W, X, sometimes a dash, and every so often you'll see a D, depending on what you're looking at. Now, very simply, R means read, W means write, X means execute because we can't use E, and that's why we chose the X. The dash is actually no permission, and the D stands for directory. Okay? And then you'll always usually see people using, command chmod, and then always have a bunch of usually 3 digits afterwards, and you have no idea what that means of why they came up with a 3, a 7, a 5, or whatever it may be. Well, that's where this little section here comes in. So what I did was I actually broke it down into 3 different things. I broke it down into the numbers, what the numbers mean, and their symbols as well. Because most of the time when you actually look up your file structure, it's not going to sit there and say 764. It's going to end up saying, dash RW or RWX, dash, 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 all the, pretty much what the symbols look like over here. So there are 7 numbers to deal with, but the basic principal numbers of usually doing the calculations is 0, 1, 2, and 4. As you can see, I have them highlighted in blue, and we'll get to that later on in the video because actually I'm jumping ahead a little bit too much. But usually if you see a 7, you should automatically know that that means read, write, and execute, as you can see here. Same thing if you see a 4, it's automatically a read. 2 is a write. If you see a 3, it's an execute and a write. So most of the time you're going to see something of this nature. Now, I'm not saying that all the time you're going to see every one of these numbers. You're probably not going to. You'll probably see select this ones and that ones. But again, we'll go over in a few examples we have later on. Now, if I scroll down here, we got to see how to view the permissions. Now, it's very simple. It's ls-l, so pretty much list. So whatever folder or file structure you're in, you always need to use ls. And the -i gives the full breakdown of the actual permissions you have here, as you can see down below. Now you can just do the ls-l, which would be your whole entire section. So if you're on the desktop, it's going to find everything and tell you everything in there. Or if you're just looking for one file name, you can just go ahead and look for the single file. as we have here. So in my output I have here, I went for ls-l, and then I got a breakdown of everything. Now you can see here I have a D. The only time you're going to see a D is when you have a folder in there. And then pretty much what it's telling me is that that directory, which is exactly what it is, a D, has read, write, and execute, and just read and execute at the end. And then I have, as you can see here, 3 files in there, and each file has something different on there. Okay, so what I'm going to do here is I'm actually just going to open up a terminal. And then we're going to actually do a little testing with this, just so everybody can kind of see. I'm going to actually use the same location I used there. So let me just go to that folder. Oops. Okay. So now if I type in ls, as you can see, it lists, just lists the actual items in there. So I have my folder that I wrote as hidden, my ID RSA, my public ID RSA, and known hosts. Now, if you don't know, this is in my SSH folder. I actually did a tutorial earlier today on SSH, so I'm kind of used to being in this folder here, and that's why I'm choosing this. I also know that each one's a little bit different as well, so it kind of gives you guys a broader view to see how everything is. So when I actually type in ls-l, it changed a little bit different. Now you see it gives you a total number of 16. Now, quick little note, this number 16 doesn't mean there's that many files in there. It means the actual system blocks that it's using. And 16 means that 4, 4, 4, and 4. It's the way it's broken down. Okay, so if you really want to see what each block is actually using or which file is using for the blocks, you hit that, it tells you right there. So it's hidden's using 4 blocks, IDA RSA is using 4 blocks, and that. But we're kind of getting off trying to get off road here with that one. So what we're doing here is we're just looking at how the files are broken. So the first one here, as you can see, is D RWX, RWX, R-X. And then you have the file there, which is just RW. Another one is RW with both read and read. And then another read and write with read and read. Okay? So when you're looking at this, you have no idea realistically how it's broken down. So what the best way of doing it is actually going back to my little cheat sheet here and just seeing how it is. So the first one here, we'll actually just use this one. So when I look at this, I know this is 600. And the reason why I know this is 600 is just because of this. All these dashes mean 0. So I know automatically that's a 600 because those are all 0. And the reason why I know it's 600 is because an R is 4 and a W is 2. So as I go back here, R, which is read, is 4, and W is 2. As you can see, I have these symbols here. And then if you go here, read and write, which if you have next to each other, like we do, okay, it is 6. So this is 600. Now you see the dash in front of it here. That means it's not a directory. You always see that at the beginning if it's not a directory because it means letting you know there's no D there for it. So I have RW and dash. So these 3 right here. Then these 3 afterwards are blank, so it's 0, and that one's 0. So my ID RSA, the actual symbol number, the numeric number is 600. Now, if I want to do the same thing with this, just by looking at this, again, I know that R and R is 4. There's no other numbers afterwards. So this is 644. And if we want to verify that, 6 is RW, and then 4 is, there we go, so 644. And the same thing with the last one there. So what does this actually mean? Because right now I know it's 600 in this and this and that. So the way it's broken down, okay, very simply is these first 3 right here is for the owner. So the user that actually owns the file. The next 3 that are blank are for groups. And the last 3 here is for everybody else. So what this is telling me here is that the owner of it can read and write, but he cannot execute the file, which would make sense because it's a text file and there's nothing to execute. All right. But the group that he's attached to has no access at all to this file, and everybody else that may be able to see this has no access to this file. They cannot read, write, or execute to it. Now for the public one here, the group actually can read it, and the other people, everyone else can actually read it, as well as the known hosts. But they can't edit the file. So if I want to actually add anything or change anything, I will be denied the changing because of them. So right here I have a quick little breakdown of if you want to actually use chmod, which is change modification to a permission in the file. Now the command to do that is chmod, and then you have to choose your permissions and then your file name. Now there's two ways of doing it. The most common way you'll see people doing it is actually this way, is where I have chmod, the 3 numerical numbers, and then after that the file name. So in this example I have chmod 764 IDRSA. Now if you want, I actually wrote a little quick cheat sheet here on how to break it down as well. So down here you can see that the most common ones you'll probably see or basics is read, write, execute, and no permission. Okay, so if I want my owner, which is the first number here, to actually be able to read, write, and execute, all I have to do is just add these numbers together. Now if you see over here, I want to read, write, execute, so that's 4 plus 2 plus 1 equals 7. So the first number will be 7. The second number is your group, and I want my group to only read and write, whoever has access to it. But they can't execute the file and everything like that because I don't want them to execute it. No problem. So again, we look over here for a quick cheat sheet for numbers and read and write. So that's 4 and 2. So we have 4 plus 2 plus 0. And the reason why we have 0 is because we're not allowing execute, no permission, equals 6. And then everybody else is only allowed to read this file. I don't want them to touch it or do anything else besides just, hey, you can look at it, and that's about it. So I'm just going to give them R, which is read. And again, if you do the simple math, it's 4 plus 0 equals 4. So the number to make it to do what I want it to do is 764. And how you would break it down here, again, like I said, user is 7. The user can read, write, and execute. The group can only read and write, and the rest of the world can only read it. So what we're going to do here is we're actually going to test out exactly what we're doing here. So I want ls-l and IDRSA. Okay. Actually, let me just go ahead and make this. Okay, so we're starting off here with 600. We already knew it's at 600. It can only read and write for the owner, and that is it. So what I'm going to do is write chmod, and like I said, we're going to do this the one we just did before, 764 IDRSA. Okay, so now I went ahead and changed it. We see that everything's successful because it doesn't give us any errors. So let's go ahead and take a look at the file one more time. Now look at that. The file has been actually changed to read, write, execute, read and write, and read. So just to see that as well, if I go actually into my home folder, so here's the file. If I go to properties here, permissions, as you can see here, everything is corresponding to what we see on the screen. So the owner has read, write, and execute access, which in this case we can't execute, but see, as you can see, it says allow execute the file, but it is just a it's just a text file, so most of the time they won't be allowed to be executed, but you can go ahead and turn it on and off if you want. Groups, as I can pick whichever group I want, but I'm going to keep it in my own, have read and write, as we can see here. And then the last only, we have the access only, the read only for everybody else. So what I'm going to do is I'm just going to go ahead and change it back to 600, and let's see what it looks like now when we go back into here on the properties. So as you see here, once I changed everything back, the owner is the only person that can read and write, and everybody else has been denied. Also, we can no longer execute this file as a program. So that's probably the easiest way anybody can actually really change a file permission. There is a second way, and it's a little bit more convoluted to do because honestly, as you can see here, it adds much more to it. You have to remember the actual O, G, U, plus, minus, and equals, plus all the RWXs, and then they threw in an extra one there called A. So we're going to go over that real quickly now too. So the second way of doing it is still doing the same command. You're going to use chmod permissions and the file name. But we have actually a few different things like operators and user denotions. And then on top of that, we have to also make sure we execute read and write. So the first operator you're going to usually see is plus, minus, and equals. And the plus pretty much means add a permission to it. Minus removes, and equals means override it completely. So whatever it's set to, we're going to make it equals, and it's going to be like, okay, that's the new permission for that. Then you have your U, G, O, and A. So U is user, G is groups, O is other, and A is everybody. So the A makes it nice if you want to change it to everyone can do whatever they want to the file, but very rarely would you want to do that, especially in a secure environment. So I threw a couple examples down here. Now, example number one, chmod O equals RWX ID RSA. So as we break it down, the user denotion is O, the operator is equal, and the permission is RWX. So as I can see here from the explanation we have down here, is what we did is that in that file for ID RSA is we changed the other permission to read, write, and execute. So say it was only read, well now it's read, write, and execute. It automatically rewrote it because the equal sign automatically changes everything to whatever we say it. Now the next one is same thing, chmod at G plus X, and then the file name, ID RSA. Now our user denotion is G, the operator is a plus sign, and the X is execute. So what we did here is we just told it to keep the same permissions, but I want you to add execute to it. So if the file had write to it, now it has write and execute using the plus sign to only the groups, not to anybody else or group. Now our third one is the user, and that one's chmod U minus R, and then again the file ID RSA. So user denotion is U, operator is the minus sign, and the permission is R. And what we just sat there and told it to do is to remove the write permission from the user. Okay. And then the last one, again, is not one you're going to see very often, but you may, all depending on the situation and circumstances, is chmod A equals RW ID RSA. So what I told the user denotion is A, the operator is equal, and permission is RW. So what I told it to do was to give read and write permission to the user, group, and other for that file. So everybody can read and write on that no matter what. So that's not bad if you want to add to everything, but it's something you may not want to use very often. And then I threw in an extra bonus little clip here. Again, you may not be using it very often, but it is something you should know. You can actually change the user and group, and the actual group for each one. So for example, it's still going to be pretty much the same setup with chon. Okay, so what that means is change owner, and then you have the word user next to it, and then you have file name. So what I'm telling you to do is to change the owner. I have to specify a user I want to change it to, and then what's the file name. So in my example here, I have change owner to root, and then the file is the ID RSA. Now, most of the time, you're probably going to want to change the user and the group if you're going to do this. You usually don't want to change it unless, again, you're in a situation where the group is HR department and we have now the HR manager quit and now we have to go to the secretary to be able to handle everything. So that might be a scenario where you just change the user and not the group. But most of the time, you're probably going to want to change the user and the group if you're going to give the file to somebody else. So it is pretty much the same setup, except you're adding a colon and group at the end of next to user. So pretty much you're going to go to, as we see here, change owner. And then we're going to specify the user and the group. And in our case, it's root will be the user and the group is root. And then the file again would be IDRSA. Now you can also just change the group as well. Again, it's not a very common scenario, but I have seen it. So might as well go ahead and explain this to you as well, because this does go under file permissions as well. Now this one we're going to use change group, so chgrp. And then we're going to specify the group name and then the file name afterwards. So realistically, we're just going to type in chgrp. The group that I chose would be root, and then the ID would be IDRSA. So more than likely, we're probably going to want to get into it and see how this thing actually works. So, okay. So what I'm going to do is I'm going to change the known hosts in this one, just to go with everything we need. So chmod, and we're going to do the symbolic method for this one. So chmod O equals RWX space known hosts. Everything looks good. So let's go ahead and check this out. So as you can see here, we changed other, I'm sorry, I actually said owner, but I meant other, to read, write, and execute for this file. All right, but I made a mistake. I don't want it to actually have execute because that just doesn't make any sense. So we're going to type in chmod. We're going to do O again for other. And then we're going to do minus X and type in known hosts. Okay, we'll go ahead and check the file. And as you can see here, we removed the execute file for them. But I want to be able to add that actually because I don't understand why my owner can't read and write and execute because he owns the file. So what we're going to do here is we're going to add to the owner. So chmod u equals, u plus w, and then known hosts. Go ahead and check that again. And as you can see, my owner can read and write just like everybody else. Now, as you can see here, which I'm actually going to go ahead and change chmod 644. Oops. All right. Actually, let's go back to the top of this. Okay. So as we were talking about before about changing user and group and everything else like that. So I'm going to actually quickly show you how to do this. Just because might as well with this one. So as you can see down here, it's change owner, user, and then the file name. So what I'm going to do is I'm going to sudo, because I'm actually going to give it to root, chmod chown, ch owner. I'm going to say root, and I'm going to be known hosts. Type in my password, and everything's good. So let's go ahead and take a look at this. So as you can see here, we went from me being the owner to now root owning it. All right, but I also want to give them the actual group as well because I don't need it. So root. Okay, and then let's go ahead and take a look at that one more time. So now you see here that they have root owns the file and the group owns the file as well. So I have no access to this as long as I'm able to read it. As you can see, I do have read available, so I'm able to go into it and actually read the file. But if I actually remove read, so sudo chmod 640 known hosts, as you see, anybody can't read the file. So let's see if I can actually get into the file. I probably will because that's how these videos usually work out. As you can see, can't do anything with it. The file is locked. I can't change anything. Root owns it all. As you can see, they pretty much blanked it out for this case because it shouldn't be where I'm at. The other problem is too, my root is actually turned off or disabled on this computer. So a lot of things will actually break at that one. So actually what I want to do is I want to give it back to me because I really don't want root to hang on to it. They're not doing very well. And then we're going back to give it all its information. So as I go back here, everything works again. So that's pretty much ends this video here. Like I said, it was a nice quick tutorial explaining Linux permissions to people and let them understand how everything works. If you're new to this, hopefully this actually helped you out a lot. Also, this will be located in the description below, so you're able to actually download this and keep it for yourself. And if you want to change anything, add to it, you're more than welcome to. If you have any, if you have any questions or comments, you can leave them down in the comment section below, and I'll be able to answer everything as quickly as possible. But like I said, you will be able to download this. This will pretty much get anybody going and understanding how everything works. And as you saw in my little quick demonstration, we're able to change files, do everything we want. We were able to change users and groups and file names. We went ahead and did a bunch of different symbolic methods for changing it. But most commonly, I recommend more people to probably just use the absolute numeric numbers. It is much easier, especially once you start remembering what numbers are what. And that's where the nice breakdown is here, because usually when I do it, I always think 4, 2, and 1, because at most they equal 7, 6. You ain't going to give anybody else anything else. But you could also get, like I said, 4 and 2 is 3. So it would be different here. So the actual ending number, 764, may not, but these 3 numbers are usually your go-to. The fourth one, no permission at 0, you can add it, but you don't need it because there is no reason for it. It's just to help you with your math when you're doing everything. So if you liked the video, like and subscribe. If you have any questions, just leave them down in the comments below, and I will go ahead and catch you guys on the next tutorial. I hope everybody has a good night, and I'll catch you later.